All right, so here we are with the 2010 AMC 10B problem 11. A shopper plans to purchase an item that has a listed price greater than $100 and can use any one of three coupons. Coupon A gives 15% off the listed price. So we'll put A and 0.15x. We'll just call the price X. Coupon B gives $30 off the listed price, so it's a flat 30. Coupon C gives 25% off the listed, or off the amount by which the listed price exceeds 100, so not the whole thing. So you have to subtract 100 from the price to get the amount that coupon C will save you. Let X and Y be the smallest and largest prices respectively, for which coupon A saves at least as much as coupon B or C. And then it wants you to select or subtract the largest price minus the smallest price that accomplishes that task. So you might think, oh, should we do like 0.85 times the price? This is the amount of the item after the discount. This is good for other problems, but not for this one. We only care about these savings, right? You want to save at least as much. So we only care about this part. So right off the bat, this needs to be bigger than that. So 0.15x needs to be greater than 30, x greater than 30 over 0.15, multiply by 100, and if you multiply by 100 here, this gets rid of the decimal point there. So 15 goes into 30 twice. X needs to be greater than or equal to 200, right? That's the price. It has to be at least that price. Okay, then for the other one, we want 0.15x to be greater than, I'm going to distribute as I write it, 0.25x minus 25. So move the 0.15 over to get 0.10. 25 has to be greater than that. Multiply by 10. You get 250. X has to be less than or equal to 250 because it's at least, meaning it can be equal to. So as long as X is less than 250 or equal to it, this will save at least as much as that. It makes sense. So 250 is the largest it can be and 200 the smallest. Subtract, get answer A. We're on to problem 12. All right, and continuing on with the 2010 AMC 10B problem 12, it was also the 12B problem 6. At the beginning of the school year, 50% of all students in Mr. Wells' math class answered yes to the question, do you love math? So we're going to have the beginning, yes equals 50%. Obviously then no would equal 50%, and 50% answered no. At the end of the school year, so this is at the end now, 70% said yes, and 30% answered no. Altogether, X% of the students gave a different answer at the beginning and end of the school year. What is the difference between the maximum and minimum possible values of X? Kind of similar to the last problem. You're min-maxing kind of stuff, and you're going to subtract them when you're done. So just think about it. If 30% said no at the end, let's go for the max first. You would have all 30% have been yeses. So that would be 30% who changed their mind. And that would mean that that leaves only 20% who still said yes at the end. All of these no's would have to convert to yeses as well. So you're going to get 80% is the max that could have changed their mind. Doesn't mean they did, but could have. The minimum possible value would be that all 50% of these stay yes, and I just take 20% of the no's away to become yeses also, leaving 30% to be no. So it would be 20% is the minimum. So 80 minus 20, the difference is 60. See you in problem 13. All right, and now for the 2010 10B problem 13. What is the sum of all the solutions of that expression? Okay, so to do this, we're going to need to understand and unpack something. How does this resolve? A minus B equals 4, let's say. then when you undo an absolute value, it's actually two results. It can equal 4, or a minus b can equal negative 4. Right? That's pretty simple, yeah? Okay, then in that case, we can take off the outer absolute value first and get 2x minus 60 minus 2x in an absolute value is equal to x. We can also get that 2x minus the absolute value of 60 minus 2x equals negative x. And so we're just going to move the x over here and the absolute value over there to get x equals the absolute value of 60 minus 2x. We'll do the same thing here, but we'll get 3x equals the absolute value of 60 minus 2x. We just do the same thing again. So you're going to get 60 minus 2x equals 3x, and 60 minus 2x equals negative 3x. Let's solve this right now. 5x divided by 5, x is 12. Add 2x, negative x will equal 60. We'll think about that one in a moment. Let's go over to these ones now. We're going to get negative x equals 60 minus 2x. So you're going to get x equals 60. And positive x equals 60 minus 2x. That gives you 3x equals 60 and x equals 20. Now you might think, oh, the 60s are going to cancel 32. They got that answer just for people like you who don't bother to check if it's true. So you have to plug it in, and obviously negative 60 cannot equal an absolute value. We don't need to evaluate the inside part. It's impossible for an absolute value to equal negative 60. If you check the rest, they will all work. 60 plus 20 is 80 plus 12 is the correct answer of 92. We're on to 14. All right, so now we're doing the 10B from 2010, problem number 14. It was also the 12B, problem 10. You probably want to watch this whole segment. There's some good shortcuts at the end in the calculation process that I think you might appreciate to understand the strategy on those. Okay, the average of the numbers 1 through 99 and x is 100x. So just pause there. What is average? It means add everything up and divide by the number of things you added. So you want 1 plus 2 plus ... plus 99 plus x, and that's x, that's one thing, and 99 things is 100 things. That's 100x. And of course, you should know that you should immediately just multiply without asking why. Most of the time. I mean, like 99% of the time, you're going to want to immediately multiply by the 100. So you have the sum of the numbers from 1 to 99. Again, these are called the triangular numbers. Their sum is n times n plus 1 over 2. The sum of the numbers from 1 to n equals this. Write it down, memorize it. If you don't want to, it's also just the arithmetic series formula, the average of the first and last, average times the number of terms. Okay, back to this. So 1 to 99 is going to be 99 times 100 over 2. Don't be anxious to divide that. You'll see why. Multiply by 100, you're going to get 100 squared x. Okay, so you might be like, why don't I just divide this into here and just work at it and then divide? But there's kind of some neat ways you can finish this problem off. If you subtract x right here, you can now factor the x out, and you will get 100 squared minus 1, and that might help you see what's going to happen if this is 99 times 100 over 2 equal to that. Then this will be 100 plus 1 times 100 minus 1. Equals this expression. What's 100 minus 1? Well, it's 99, and there's a 99 over here. So now, yeah, go ahead. I guess you do want to get that 50, and then you're going to divide by 101 to get x. That's answer choice B. All right, and this is the last problem of this set, which is the 2010 AMC 10B problem 15. On a 50-question multiple choice math contest, students receive 4 points for a correct answer, 0 points for an answer left blank, and -1 point for an incorrect answer. Jesse's total score on the contest was 99. What is the maximum number of questions that Jesse could have answered correctly? You might be thinking, let's make an equation, right? We could do 4 times the number that he got correct minus 1 times the number that he got wrong, and you might think that that could be like 50 minus x, but this doesn't say how many he could have left blank. there's no guarantee that this will actually equal 99, and in fact it doesn't. So what you want to do instead is just use the answers. Like pick one in the middle because they're order from least to greatest and try it out. So we'll try 29. What if he got 29 right? Well, 4 times 30 is 120, so if I subtract 4, this must be 116. Now, could he get from 116 back to a score of 99? Yes, if I simply got 17 wrong and skipped the rest. And that's 29 plus 17, that's less than 50 total questions. The other ones could be considered skips. But it seems like there's a lot of play in this number. We could probably get a little higher. Let's try 31 and see what happens. So 4 times 31 is 124. He would have to get 25 wrong in order to get back down to 99, but that would be 31 plus 25. He'd have to answer 56 questions, and I don't know how that's possible. So the answer must be 29, but still, it kind of makes you curious to know if 30 would work. If he answered 30, he would get a score of 120, right? 30 for that part of it. And then you would subtract 21. But if he got the 30 right plus the 21, that's still too many questions. It really is answer choice C.